Complex fractions. In this section, we're going to simplify complex fractions. And before we begin, we need to at least define what's a complex fraction. A complex fraction is a fraction. We have a fraction bar that's located here. And the numerator has a fraction, the denominator has a fraction. So a complex fraction is where the numerator and or denominator will have a fraction in it. So our goal is, of course, is to simplify, but we want to eliminate the denominators that's in the numerator and denominator. And what I have highlighted in yellow, that's what we want to get rid of. And how we're going to get rid of the denominators is first by finding the LCD. So for question 1, we have 6 over 2x all over 2 over 4x. So what we're going to do is find the LCD for the denominators that I have highlighted. So remember the Venn diagram that we've talked about, that we've been using to find the LCD. We're going to let the first circle represent 2x. The second circle, we have 4x, but we're going to write the prime factors for 4x. We have 2 times 2 times x. So where the circles overlap, that's where we want to write what's the same. What factors do you see that's the same that we have here? We have a 2 and we have an x. So our first circle represents 2x. Our second circle, we want to represent that as 4x. But what is different? What makes the second circle different? Which will be an additional 2. So we're going to multiply those factors together. 2 times x times 2, we have 4x. So step 1, we're going to find the LCD. Step 2, we're going to multiply the LCD to the numerator and to the denominator. And we'll talk about if we have more than one term in the question and what must we do. So we're multiplying the 4x to the 6x over 2x, and then we're multiplying it to the 2 over 4x. So next, what we're going to do is divide. We want this denominator that's highlighted in yellow to divide into the LCD. So numerator, the x's divide out. 2 divides into 4 twice. Then we're going to take this 2, we're going to multiply to the 6 in the numerator. We have 12 all over. Let's look at our denominator. Let's look at the denominator, the 4x. Does it divide into our LCD? It does. So the 4x's divide out and we're left with a 2 that's remaining. And then we have a fraction that's in reduced form. And then 12 over 2, reduce that, and we have a solution of 6. So a complex fraction, first find the LCD. Then we're going to take the LCD, multiply it to the numerator and to the denominator. And if we had terms, meaning our numerator was a binomial, or at least a binomial, as well as the denominator, we would multiply the LCD to every term. And then we would divide, we would reduce each term, and then simplify the complex fraction. Let's do another example. Example 2. We have here, this is number 2. We have 5 over x minus 2. That's all over x minus 2. So we want to find the LCD. And let's look at our denominators of the complex fraction. Those denominators, we have an x minus 2. So what we're going to do, well, the LCD. Find the LCD, which is x minus 2. We're going to take the x minus 2. We're going to multiply it to the numerator and denominator. And we're going to simplify each numerator and denominator. So the x minus 2 in the numerator, that divides out. Okay, so the x minus 2's divide out. We're left with a 5 in the numerator. And then in our denominator, what divides out here? The x minus 2's, and we just have an x that is left over. So our solution is 5 over x. It reduces to a fraction, so please do not write 5 times x. It's not 5 times x. We have a 5 in the numerator, an x in the denominator. So our solution is 5 over x.